right, 3.3. So hopefully this is still a little bit more review. The biggest thing today when we look at inequalities is going to be the shape. That's going to be the biggest difference, okay? So 3.3 is all about graphing and solving systems of linear inequalities. So we're going to have less than or equal to, greater than or equal to, and then less than and greater than. What do we have to remember, kind of going back to piecewise functions, when we have inequalities? When we graphed them, we had the open and closed dots, right? Well, instead of having the open and closed dots here, you're going to have a solid line or a dotted line. So which is going to be which? Which one should be a solid line? When you have an equal to, very good. And then the dotted line is when it's just less than or greater than, okay, because you're not technically going to include, okay? All right, so graphing these, it's still just a system. You're going to have 2 or 3 or 4, whatever it may be. But instead of being equations, they're just inequalities, okay? Your solution, those are still ordered pairs, but instead of having just one where they intersect, you're going to have a bunch that could be possible. And that's going to come from the shape, okay? So let's just jump right to it. All right. Here we have y is greater than or equal to negative 3x minus 1. And y is less than x plus 2. All right, so what do I need to do here? What am I going to do with these? Logan? Okay, you're just going to graph them like normal. Okay, so first one, how am I going to graph that y is greater than or equal to negative 3x minus 1? Logan?
Go down 1 on the y-axis, and then your slope is negative.
Right, you just graph it like a normal line. So treat it as y is equal to negative 3x minus 1. The only thing is you're going to have to remember to go back to the inequality when we shape. Okay, so I go down to negative 1, and then I apply the slope of negative 3. So 1, 2, 3 down over 1. 1, 2, 3 down over 1, and then I'll reverse it. 1, 2, 3 over 1, 2, 3 over 1. Okay? I'm going to cheat and actually get this straight here. Okay, now, with it being greater than or equal to, should I have a solid line or a dotted line? Solid. Let me angle that a little bit. Cheating a little bit today. Okay, so now let's graph the second one. So I'll graph that in green. So y is less than x plus 2, treated as y is equal to x plus 2. So where's my y-intercept? Up at 2. Make sure we're off cell phones. Please and thank you. All right, then my slope is what? Yeah, it's just 1. So up 1 over 1. Up 1 over 1. So on and so forth. Okay, this one though is y is less than. So what should that line look like? It should be dotted. Very good. All right. Stretch this out a little bit more. Okay. So I still have one intersection point. But I'm not worried about that intersection point anymore. I'm really looking at the shaded region. Okay, so if it says, let me write these, y is greater than or equal to negative 3x minus 1. So my y value should be bigger, right? That's what greater than means. So in terms of where my y values are bigger, am I going to shade below the line? Or am I going to shade above? You're going to go above. Okay, so let's shade that in. Okay, so it'd be all of that for being above. Then for this, y is less than x plus 2, my y values are smaller, so you're going to go underneath. Very good. Okay, so it's all of this. And then the only thing I'm really concerned about is where they overlap. So actually, I'm going to erase all of the extra. I erase all of that, and I erase all of this up here. So you don't need it. Nope. You really only care about where the two shaded regions overlap. Does that make sense? All right, so any questions on that one?
So that's just our answer, like.
The shaded region, yep. Because if you think about it, we can have, now because we have inequalities, we truly don't just have the one answer like we did. We have one spot where they intersect, so that's still a point that could be true. But then we have all of this as well. So now we kind of have more answers in a sense.
Like on our homework, we only see it in different colors?
No, you don't have to. Yeah, if you're just doing this in pencil, you can like do it lightly both ways, but then darken the overlap. That's okay. All right, try this one. Y is greater than or equal to -2. X is less than 4. And then you have -1/2 x plus y is less than 1. What's easier to graph it? Slope-intercept form or standard form? Slope-intercept form. Now, what is this last one in? That's in standard, yep. Okay, so let's change that first off. Let's get y by itself, so add 1/2 to both sides, 1/2 x. So now it's y is less than, I'll write it as slope-intercept, so +1. Okay, so these are the ones with the dots that I'm going to graph. What do you have to be careful of if you divide by a negative? You have to flip the inequality. Okay, that's going to be very, very important to pay attention to if you're going from standard form to slope-intercept form. Okay, now, y is equal to -2, x is equal to 4, and then you have a normal line in slope-intercept form. So be careful of how you graph. So what are you going to do for the y is equal to -2? Where do I put my dot? Up, down, left, or right? Down. Yep, it goes down at -2. Okay, and then what kind of dot should it be? Or, excuse me, not dot. What kind of line should it be? It should be horizontal, and is it solid or dotted? It is solid. Good. So my line will go through that point. All right. And then where are we going to shade for that one? Above or below? My y values get bigger as I go up. Very good. And I'll shade at the very end. Okay. What about x is equal to 4? Do I go up, down, left, or right?
Right.
Yep, it's the x value. So you go to the right, 4. And then what kind of line is this? Horizontal or vertical? Vertical through that point. Very good. And it is dotted. Okay, now, am I going to shade to the left or to the right? Left, because my x values get smaller as I go to the left. Very good. And then just graph that one normal. So you go up 1. And then my slope is up 1 over 2. 1 over 2. Down 1 over 2. Down 1. Okay, and then this line, because it's less than, it should be dotted as well. All right. Now, we've graphed all of those perfectly fine. Now, the big thing is, where do I shade? Okay. So if, like we said before, if I have the y is equal to -2, it's greater than, so I shade above, right? So I'm just going to shade above. Okay, and it would be everything above there. All right, so then if I have x is less than 4, that was my vertical line. So do I shade to the left or to the right? To the left, yep. So I'm here. Okay. Now my slanted line, that is the y is less than 1/2 x plus 1. So think of this as being above, so when you're getting bigger on your y's, and below is when your y's are getting smaller. So am I above or below? If it's y is less than. Below. Where am I overlapping? What's that? In the triangle, good. So it's really messy. So let me erase. So I don't need any of this down here. Okay, I don't need anything above, oops, moving on. Don't need anything over here. I'll go along that line. So this is all gone. Need to calibrate this. And then I don't need anything to the right of my x is less than 4. So that is where I'm shading inside that little triangle. Do you guys kind of remember doing some of these? Hopefully, good. All right. Shading is going to be probably the one thing we'll go over with each problem. Okay, that's usually where we kind of have some hiccups. But as long as you really think of what it means, what does it mean where my y values get bigger? Or what does it mean where my x's get smaller? As long as you understand that in terms of the coordinate plane, you'll be just fine with shading. Okay? All right, and then your favorite types of problems. You'll learn to love them, I promise. Yeah, probably. All right, so this one says, a medical study requires participants to be between the ages of 18 and 55 and between 60 and 74 inches tall. So we need to write and graph a system of inequalities for the participants. All right, so what do you guys think? What are my two inequalities going to be? What are they going to look like? What do we think? We know we're dealing with age and height, right? Okay, because those are the only numbers we have. What do we get? What numbers are we going to use? Let's start there. What are the only numbers you see? Logan?
18.
Yes. Right, 18 and 55, and then 60 and 74. Okay, so let's start there. I know I'm going to use these. Okay, so I need to be between there for this study. When you graph, you usually need the categories on the bottom and then what you're measuring along the y-axis, right? So my category here would technically be what? What is my category? How am I classifying these people? By the ages. Very good. So ages would be which value? The x. So x is going to be between 18 and 55. So that leaves y to be the height. Does that make some sense? Okay. This is going to be in inches because that's kind of what you're measuring. And then ages will be in years. That's your category, basically. Okay. Now, actually, let me move. All All right, so how do my inequalities look then? This is my x, this is my y. You have to be older than 18, right? So 18 what to x? How does that relate? So x, yep, 18. So x is greater than or equal to. So 18 is less than or equal to x. Because we can be 18, right? And then what about 55? How does x relate to that? What? It's less than or equal to, right. So basically you can be between 18 and 55 and still be those ages. So 18 is less than or equal to x, which is less than or equal to 55. So what about the y's? Can I be 60 inches tall? Yes, I can. Can I be any shorter? Nope. So x is going to be bigger, or excuse me, y is going to be bigger. And then can I be 74 inches tall? Yep. Can I go above that? Nope. So it's again that string of inequalities. So 60 is less than or equal to y, which is less than or equal to 74. Okay. And just for space here, let's see. Let's go by tens. Will I have enough? So 10, 20, 30, 40. Yep, I will. Okay, so go by tens, graph these out. So go by tens here. Let's start with the x values. I'm going to put a dot at where I think 18 will be. And I'm going to put a dot at where 55 would be. Vertical or horizontal lines? For x. Vertical. And then am I dotted or solid? Solid, why? Because it's equal to, very good. All right, so then just draw a straight line. Go through that point. Oop, moving the dot. Okay, do the same thing for the y's. So put a dot at 60 and a dot at 74. So hopefully you realize those are going to be horizontal, going through those points. And then dotted or solid? Solid, very good. Okay. So now I need to figure out where I'm going to shape. So I know I'm going to be between 18 and 55, so I'm in here all the way up and down. And then I know I'm going to be between 60 and 74, which are these right here. So do you guys see the overlap? Basically that little rectangle, right? So I'll erase everything else and leave us with our answer. All right, does that make sense? Awesome. All right, are there any other questions for graphing and solving inequalities for the systems? All right, here's your homework.